Hey everyone, in this video we are going to talk about definite integrals. So sometimes we don't want to find the antiderivative of a function, right? Sometimes we don't want to just integrate so that we know the whole function. Instead, we want to know the area between a curve and the x-axis. So this is where definite integrals come in. All right, these integrals have bounds on them that show the left and right sides of the area that we want to find. So it looks exactly the same, but we've got a lower number and an upper number. And we say this is going from a to b of f of x dx is this area. So you can see in this picture we've got our function curve here. We've got our left and right hand limits, a and b. We start at a, we go up to b, right? That's why a is on the bottom, up to b. And if we do this, if we evaluate this piece, it's this area, this blue A. This area is the total area here between the curve and the x-axis, and we can calculate it with this integral. And this brings us to the fundamental theorem of calculus. All right, to find the value of a definite integral, we can use the fundamental theorem of calculus to help us. All right, this theorem connects derivatives with integrals. All right, it connects differentiation with integration. It brings them all together. That's why it's called the fundamental theorem. All right, so if you have a continuous derivative, f prime, on your whole interval, a to b, then the integral from a to b of f prime of x is the original function. So this was the derivative, right? The original function at the point B minus the original function at the point A. So if you're integrating and you have this definite integral that you're doing, you can evaluate the function, or you can integrate the function using the rules we've talked about in other videos, and then take that integral, that new function, and evaluate it at the point B and at the point A, find the difference, and you've found that total area. So let's talk about some properties of definite integrals. All right, these are really important properties to understand. The first thing we're going to do, assume that A is less than B. So assume, just like in this picture, we're always going from left to right, from A to B. Okay? So the first thing is if you're taking the integral of 0, it's 0. If your function is right on the x-axis, if it's at 0, there's no area under that. So no matter how long you go, there's no area there, you're at 0. Then, this is saying the integral from a to a of a function is 0. So if you're at a single point, there's no area there. The area is 0 at that single point. All right, it doesn't matter how high the function is, because that line doesn't have any actual width. There's no area, and so the integral from a to a of a function is 0. Now, look at this. This one's kind of tricky. The integral from b to a. So this is kind of going backwards, right? B is bigger than a, so you're going backwards. Integral from b to a of f of x is the same thing as the negative of going from a to b of your function. All right? So if you flip your signs, or flip your limits, right? If a and b flip, the value just becomes the negative of what you had. All right? This next one, integral from a to b of a constant times your function. Well, the constant can just come out front, and it's the constant times integral from a to b of f of x. All right, so that constant can just kind of hang out just like it has been doing. Similarly, definite integrals over addition or subtraction, you can split it up. All right, if you have integral from a to b of f plus or minus g, well, you can do integral from a to b of your function f plus or minus integral from a to b of your function g. The last property we're going to talk about is this idea that you can split up an integral. All right? So if you have a function that you're integrating from a to b, you can pick a point in the middle, call it point C. You can see C is here in between a and b. And you can split it up, and you can say integral from a to b is the integral from a to c of your function plus the integral from c to b of your function. So it's kind of like saying, all right, well, if I want to find the total area, I can find the area of the first half and then find the area of the second half and add them together. Why would you do this? There's all sorts of reasons. You could do it if your function is piecewise, all sorts of other things. All right, but this is something that you're allowed to do, and it's a super important one to remember. All right, hopefully these properties help get you started down the right path, jog your memory. As always, thanks for watching. We'll see you next time.